Okay. Hello everyone. I am Subroto Pramanik. So I am giving a demo on very short but interesting topic, that is the concept of gravitational field and the electric field. The concept of gravitational field or electric field basically are almost same, but the basic difference between these two gravitational force and the electrostatic force is that the gravitational force is basically acts between two masses or two bodies, and the electrostatic force which are being developed between two electric charges. So we know the gravitational force between two masses, one is of mass capital M and other is of mass small m, is given by the Newton's gravitational law, that is given by F vector is equal to gmm by r square into r cap, where r cap is the unit vector along the joining line of the two bodies. And if in case of electrostatic field, if we put two charges to a possibly 2 point charges, if we put 2 point charges in free space, which is basically denoted by epsilon 0, which is the permittivity of the free space, then the force of attraction or repulsion acting between these 2 point charges is basically given by Coulomb's law, and this is given by F vector is equal to 1 by 4 pi epsilon naught q1 q2 by r square into r cap, where r cap also being the unit vector along the joining line of the two charges. Now the basic concept or of the gravitational field or and the electric field are basically almost same, but there is a nice concept in whether it is gravitational field or the electric field, is that what is gravitational field? If I put a mass capital M here, the space around the body, by far we can experience the gravitational attractive force due to this mass. The space of the region due to this mass is known as the gravitational field. That means इस चार्ज के आसपास जितना दूर तक हम लोग इस चार्ज का ग्रेविटेशनल एट्रैक्टिव फोर्स को एक्सपीरियंस कर सकता है, उस रीजन ऑफ स्पेस को इस चार्ज के द्वारा तैयार हुआ एक ग्रेविटेशनल फील्ड हम लोग बोल सकते हैं. बट देयर इज ए कॉन्सेप्ट इज दैट let us consider that this is the region of space. By far I take that this is the region in between which the gravitational field due to this mass has been created, but there is a gravitational field. This cannot be confirmed by this mass as long as we have to take a very small mass del m here, where del m is very less than m. And now if this mass experiences an attractive force due to this mass, then this body can confirm that there is a gravitational field due to this body. Why is this like? Because we know everybody in this universe attract each other with the same force. But now if I consider there is a gravitational field in this region due to this body, if we put another body here, if this body experiences a force due to this body, then this body can confirm that yes, there is a gravitational field due to this mass. Why such experience? because this body, this del M, have experiences a force due to this body. That is, when I take the body in this region, there are some gravitational force which basically spreads from that body to that body, and the medium due to which the gravitational force of the body of mass capital M spreads into the body of mass del M is the gravitational field. Now, from this lecture, one thing I can conclude that the process of spreading the gravitational attractive force from a body to the another body is a two-step process. In the first process, we have to put a body and we have to consider the body has created a gravitational field around it, and if I put a very small body nearby to the body, and if the body experiences a force due to this, then this body can confirm that there is a gravitational field, and for this gravitational field it experiences the gravitational attractive force. And one thing, why this mass is very small than this mass? Actually, this mass is known as the test mass. That is what? We have taken the mass here to test whether there is a gravitational field or not around this body. So if we take this mass greater than that mass, it should have some effect on it. But this was not our motivation. Our motivation was to see whether there is some gravitational field or not due to body. If this mass would be greater than that body, it would have some effect on it. Then the whole system will be disturbed. That's why this mass is to be taken very less than this capital M. That is for gravitational field. In case of electric field, if we keep a point charge q here, and if we consider that this is the electrostatic field, similarly, if we put here a very small charge, that is del q, which is also known as test charge, and if this charge feel any attractive or repulsive force due to this positive point charge, then this charge can confirm here also that there is an electrostatic field due to this point charge here. And similarly, we can attribute that if this body experiences a repulsive force due to this charge and also the attractive force due to this charge, that is the medium for which this test charge experiences an attractive or repulsive force is the electric field, due to which the attractive or the repulsive force has spread towards it. And one another thing, people says that the gravitational field or the electric field